Hi students, in this video we will see the first unit of biosignal processing. Our first unit is introduction about digital signal processing. We just learn about the basics of digital signal processing. What defines signal, what are the types of signals are there, then the elementary of the signals, the basic operations of the signal. We will see these kind of topics in this video. You never skip the video, you will see the full video. If you have any doubt, you just mention in the comments. I will reply you. Now we will move to the topic. The first topic is the definition of the signal. First we see the definition of the signal. The signal is a function of one or more independent variable that carry some information to represent a physical phenomenon. For example, ECG signal, EEG signal. The signal is majorly classified into two types. One is continuous time signals, another one is a discrete time signals. First we see about what is continuous time signal. Whenever the signal is varying with respect to time, this is called as a continuous time signal. Next we will move to discrete time signal. The discrete time signal, the signal is varying with respect to amplitude, that is called as a discrete time signal. This signal that has a value for only specific points in time. It's typically formed by sampling, that is we just take a number of samples in the given signal. A continuous time signal, it taking the value of the original waveform at specific interval in time. The function of the samples values of n, it's write as a x of n. It is also called as a sequence. It commonly found in the digital world. The example of continuous time signal and discrete time signal. The signal is varying with respect to time. Here the signal is varying with respect to amplitude. Next one is a sampling. Discrete time signals are often obtained by sampling continuous time signal. Whenever you are giving the x of t, that is the input of the signal, we get x of n is equal to x of t. Here t is equal to n into t. The next topic is elementary of signals. There are different types of elementary of signals are there. First one is a unit step signal. Unit step signal is nothing but that u of t is equal to 1 for n is greater than equal to 0. Suppose u of t is equal to 0 means for n is less than 0. This is a condition of the unit step signals. Next elementary of the signal is unit ramp function. Unit ramp r of t is equal to t and 0. T is greater than 0 means the value is equal to t. The t is less than equal to 0 means the value is 0. This is a condition of unit ramp function. One is a unit impulse function. Here the a approaches 0, that is the g of t approaches a unit step and g of t approaches a unit impulse. This is an example of unit impulse function. Unit impulse function is a derivative of the unit step function, or unit step is the integral of the unit impulse function. This is a representation of impulse function. The area under an impulse is called its strength or weight. It is represented graphically by a vertical arrow. An impulse with a strong of 1 is called as a unit impulse. This is an example of unit impulse. This is a shifted impulse of amplitude 5. Next one is the properties of the impulse function. The first one is the sampling property, second one is the scaling property, and third one is the replication property. Next elementary of the discrete time signal is unit impulse train. Unit impulse train is a sum of infinity and formally spaced impulses and is given by del t of t is equal to sigma n is equal to minus infinite, the limit value minus infinite to plus infinite, and del of t minus nt. Here n is an integer. This is an example of del of t. Next one is a sinusoidal and exponential signal. Sinusoidals and exponential are important in signal and system analysis because they arise naturally in the solution of the differential equations. The sinusoidal signal can be represented in either of two ways. First one is a cyclic frequency, another one is a radiation frequency. The radiation frequency is denoted as omega naught. The omega naught is equal to 2 pi f naught. Here t naught is time period of the sinusoidal wave. In our next video, we will see the basic operations of the signal. Thank you.